grade 11s, we're moving on to our next topic within trig, which is trig equations. Now, trig equations can become a little bit interesting and a little bit difficult, just because there's just so many things that could come into a trig equation. So in order to try and make it a little bit easier for us, we're going to go through it quite slowly, and I've broken it down into various topics, and I've called them different levels. And basically, every time we go up a level, we learn something new. So this video is just on your basic trig equations, the absolute basics, and so I've called it level 1. So our first example says solve for theta in the following equations, and the equation says sine theta is equal to a half. Now I think the most important thing here is to remember what we learned about the four cousins. The four cousins taught us that there are 4 places in the Cartesian plane where sine theta would be equal to a half. 2 of them will be positive and 2 of them will be negative. So how do we find out kind of like our first of the 4 cousins? And I'm not too sure if you remember from grade 10, but if you use the sine button on your calculator, you then have to put in an angle. So for example, you do sine of 30 and you put in the angle. And if you push equals, it gives you out a ratio. So now we need to learn how to do the opposite. How do you tell your calculator that you're going to put in the ratio and you want to go back to the angle? And so that's on your calculator is the inverse function of sine. Remember, the inverse means to go backwards. So that is sine to the negative 1. Now that negative 1 is not an exponent, that's just a notation. So basically to get this thing, we use shift on our calculator and then we push the sine button. So try it on your calculator, push the shift button, push sine, and you'll notice on your screen that it says sine to the minus 1. Now again, that's not an exponent, it's a notation to say that I must put in the ratio and my calculator will work backwards to the angle. It's called an inverse function. So I just want to say that again. If I'm trying to work backwards from the ratio to the angle, I use shift sign, which has a notation of sine to the minus 1. Then I put in the ratio and it works backwards to the angle. So in this case, for example, I'm going to put shift sign, which is sine to the minus 1. I'm going to put in my half, and if I push equals, it gives me an angle of 30 degrees. So what that tells me is that 30 degrees is one angle in the Cartesian plane that has a ratio of a half. Now, I've said this many times, there's 4 cousins in the Cartesian plane. They all have a ratio of a half. So there's this angle here, there's this angle there, and there's that angle there. All 4 of these will have a ratio of a half for sine of that angle. So how did we make them? Well, don't forget, if we reflect over the y-axis, we would get this angle. So the angle formed, it should be that. So that is 150 degrees. Why? Because it's 180 degrees minus the 30 degrees because of the reflection. The next angle is this could be 30 degrees. So the entire angle formed would be 180 plus 30. So this would be 210 degrees. So far we know 3 of the 4 cousins are 30 degrees, 150, and 210. And finally, this could be 30 degrees, which means all the way around the angle formed would be 360 minus 30, which would be 330 degrees. And so that basically gives us our 4 cousins: 30 degrees, 150 degrees, 210, and 330. All 4 of these will have a sine ratio of a half. However, 2 of them are going to be the negative cousins, and 2 of them are going to be the positive cousins. Now, in this particular example, if you have a look here in the equation, this is sine is positive a half. So the negative cousins are not at all useful to me. Now, where are the sine? What are the signs for sine? So it's all stations to Cape Town. So this angle here, which is in quadrant 4, this is going to be the negative cousin, which is not the angle that I'm interested in here. This angle here, this 210, which is this angle there, this is going to be a negative cousin, which I'm not interested in here. So what am I interested in here? In this example, I want to know where it's positive a half. And so the positive cousins are 30 degrees and 150 degrees. And so those are my 2 answers here. Okay, but now every single time I do an equation like this, I don't want to have to figure out the 4 cousins and figure out everything. So how do I actually go straight to the two of the cousins which are asked for in this question? Well, the first thing is you literally just do shift sign of the ratio, and your first answer will come directly from doing that. If you just say to your calculator, shift sign of a half and push equals, your calculator would say 30 degrees. Or, how do we get the second answer? The second answer is 180 minus 30. Now that makes sense because this is sine, and sine has its second solution in quadrant 2. So I'm just going to write myself a note here. This is quadrant 2. And so notice that sine has one of its answers in quadrant 1 because that's where sine is positive, and it has its second answer in quadrant 2. So something that's really important is for you to understand that every trig equation has two answers in the first 360 because two of the cousins are always positive and two are negative. So there's always two of the cousins which kind of fit the description for this particular equation. Great. And so I just need to finish off my solution. So theta is equal to 150 degrees. That's great. So there's my solutions, 30 and 150. Now the only problem is, and this is something we haven't discussed in grade 10, are those the only two answers that work for this equation? We learned when we learned about angles that are bigger than 360, we learned that if you draw an angle in the Cartesian plane, so for example, if I drew 30 degrees, we learned that I'm allowed to add 360 as many times as I want, and nothing will change because I will land up at exactly the same position. So 30 degrees is actually exactly the same as 390 degrees because all I've done then is I've gone a full revolution round and come back to where I came from. In fact, I could minus 360 as well. So if I minus 360, I could go all the way back to where I came from, and that would be minus 330 degrees. So minus 330 degrees is also the same as 30 degrees. So the reality is you are allowed to add and subtract as many multiples of 360 as you like. So how do I write that? How do I say that the answer is 30 degrees and I can add as many multiples of 360 as I want, and I can subtract multiples of 360? So what we do is we write plus and we write k 360. Now the k is there because k can be any integer. So I'm just going to write this in every single line, and then I'm going to explain what it means and write a note on it. So k is m to z plus k 360. I hope you remember this k is an element. This sign here means is part of, and z are your integers. So what does this mean? Basically this means that you can add and subtract a multiple of 360 as many times as you want. So the k is there because k could be any integer, so k can be 1. So you could add 1 times 360, or k could be 2. So you could add 2 times 360, or k could be 3. So you can add 3 times 360. Notice you can't add 1.5 times 360 because we've said k is an integer, so it's not allowed to be a fraction. Now k could be negative 1, so that means you would be minusing 1 lot of 360, and all that means is that you can go all the way around and come back to where you came from. So I've just written myself a note here that plus k 360, but k is an integer, means that you can add or subtract as many multiples of 360 as you would like, and you'll get an angle that sounds different and it looks different. 390 degrees looks different to 30, but it's effectively exactly the same angle, and it'll have exactly the same x value, exactly the same y value, exactly the same r value, and so the sine, cos and tan of 390 is exactly the same as 30. So in reality, how many answers are there to any trig equation? There are infinitely many answers because you can just keep adding 360 as many times as you want. There's only 2 answers in the first 360 degrees. So we find them both. So I'm going to put a little 1 here, and this is a little 2. So we find both answers, and then we add on what I call the surname, the plus k 360, to explain that you could just keep going forever. Okay, let's try some more. So let's look at a cos example. So if cos was a half. Now, again, I know that there are two answers in the first 360, but instead of finding all four cousins, let's just think about it. Where would we expect answers for cos being positive? We know there's four cousins, but we know that two of them are positive. So it's all stations to Cape Town. So we're looking at answers in quadrant 1 and quadrant 4. So our first answer, and I wouldn't write this part in a test, but just because this is our notes, I'm going to write in grey what we need to do. So we'd pick up our calculator and we'd say, calculator, we want to put in the ratio, so we need to use shift cos. So we're not cosing a half, we are saying I am putting in the ratio and I want to work backwards to the angle. Now I would never write this down in a test, I would do it on my calculator. But if I do shift cos of a half, my calculator tells me that 60 degrees is the right answer. So cos is equal to a half at 60 degrees. So what would I write in a test? I would literally just write theta equals 60 degrees. Okay, but that's not entirely true. Yes, it's equal to 60, but I can add as many multiples of 360 degrees as I want. Or I can subtract as many multiples of 360 degrees as I want. So k has to be an integer, but basically I can add 360s or I can minus 360s. Right, so where's our second solution? We know that second solution is in quadrant 4. The question is, how do we work in quadrant 4? Well, quadrant 4 is all the way around there. And remember, how do we work in quadrant 4? This would be 60, and we would fold it over and get that as 60. So our second solution to work in quadrant 4, we say 360 degrees minus 60. Okay, but you've got to add on the surname. The moment you write down a solution for theta, you've got to add on the fact that plus any multiple of 360 degrees. So actually this then becomes 360 minus 60 is 300 degrees plus k360. K is an element of integers. So once you start getting really good at this, you start leaving out this line and just doing the 360 minus 60 on your calculator. We are going to come across examples that get a bit tricky, and therefore we need to write down the first line. But in these easy ones, we can go straight to that answer of 300 plus 360. So that kind of makes sense. You can always check on your calculator. Go check cos of 300 degrees and check that it's a half. Okay. On to our next example of tan, and then we've done one of each. Now tan is a very special one, because where is tan positive? Why am I looking for the positives? Because in this case I said where is tan theta equal to positive 1. So it's all stations to Cape Town. So my answers are going to be in quadrant 1 and in quadrant 3. So first thing I'm going to do, on my calculator I'm going to shift tan. So shift tan of 1, and I wouldn't write this in a test. On my calculator I get 45 degrees. So this tells me this is 45 degrees. Now how do you find an angle related to that in quadrant 3? Well, this is 45 degrees. So this angle in quadrant 3 will be 180 plus 45 degrees. So my two solutions are, first of all, I get theta is 45 degrees, and then I have to write plus k 360. K is an element of integers. Secondly, theta must be 180 degrees plus 45, because that's the answer in quadrant 3. Plus k 360. K is an element of integers. Therefore theta is equal to 225 degrees plus k360. Okay, so now we've done one example of all of them. Now, a really important thing about tan. Tan, like sine and cos, has two solutions in the first 360. However, sine had answers in quadrants 1 and 2. So there was no symmetry about the answers. Cos had answers in 1 and 4. Again, there was no real kind of connection between the answers. However, tan is very special. If you look at this first angle, this first answer of 45 degrees, it is connected to the 225, because if I just add 180 degrees to the 45, I get to that second answer. Now, if I add 180 degrees again, I get back to the original. It'll obviously be a full 360 degrees later, but we've already discussed the idea that you're allowed to add 360 as many times as you want. So with tan, do we have to write down both of these? Is there a way to condense them into one line? And the answer is yes. You could just do shift tan, and so you get 45 degrees. And instead of writing plus k360, we write plus k180, because k is an element of integers. So what does this do for you? It's different to the original, and it's different to sine and cos. But the reality is, if you just look at the second solution, the answer is 180 plus the 45. So there's nothing wrong with finding the first answer and then realizing if you just add 180, you will automatically generate the second answer. And then if I add 180 degrees again, I'll go straight back to my first answer just a full revolution later. So basically this can condense, these two solutions can condense down to one statement, except it's different to sine and cos because it's plus k180. So in future, we don't bother writing down two separate solutions for tan. We put down the first solution, but instead of writing k360, we add k180, because that will automatically generate that second solution. Okay, so I've just written myself a note there that says exactly that. So hopefully you can get that note down, and that means from now on, tan, the moment you see a tan equation, you do a jump for joy, because they're just such easy equations, because you don't have to worry about the second solution. Okay, we're going to move on to example 2, where I'm pretty much asking exactly the same questions. I'm just asking for the negative cousins, and we're going to see how our calculator can help us do those. So let's have a look at the first one. Sine of theta is negative half, and purely because of what I did in the first question, I kind of already know the answers. But let's have a look. All stations to Cape Town. Where is sine negative? Sine is negative in quadrants 3 and 4. Now, how do I get my calculator to find those? And here's the beauty. You don't have to worry. Your calculator is clever enough to do it for you. So literally, I would pick up my calculator and I would say shift sine of negative a half, as per usual. We don't ever write this down, but just so you have a note on it, shift sine of negative a half, and your calculator gives you negative 30 degrees. And you might be going, what? Where is that? Negative 30 degrees. Remember, negative means you just go in the clockwise direction. And so guess what? Negative 30 degrees is in quadrant 4. So your calculator has found the quadrant 4 solution. So you don't have to worry about how do you find the quadrant 4 solution. What do? Your calculator does it for you. So literally my first solution is just theta equals negative 30 degrees. And we never forget that with sine and cos, it's plus k360. K is an element of integers. Now, if you go back to question 1, you'll notice that the 4 cousins were 30, 150, 210, and 330. And this isn't one of the 4 cousins, but careful it is. If you take negative 30 degrees and you add 360, which you are allowed to do as many times as you want, you get 330 degrees. So you just need to be a little bit careful when you mark questions like this from memos, because often you'll see their answer in the memo is 330 and you're like, oh, how did I get this wrong? And you have to realize that you didn't get it wrong. So always just check, is negative 30 the same as their answer? So let me just add my 360 and see if I get that. Okay, so now the question is, how do I find my second solution? Now again, this is the beauty of trig equations. You don't have to change your method at all. If we go back up to question 1, where we did our first sine equation, how did we find our second solution? Our second solution was found by doing 180 minus the first solution. So this is exactly what we're going to do again. So our second solution is going to be theta is 180 minus our first solution. And you might be like, but that's weird because I swear this answer is meant to be in quadrant 3. Why am I doing 180 minus? Now this is the beauty. A minus and a minus make a plus. So you actually get 180 plus 30 degrees, which is 210. And what do you know? This is our quadrant 3 solution. Now the only thing is I need to write my plus K360. K is elements of integers, and I have to put it down both times. So this is the beauty of trig equations. You don't have to remember two different ways to do things. When we write a summary in a moment's time, basically with sine, you do shift sine, and that's answer number 1. And then you do 180 minus that answer, and you do the same thing every time. It doesn't actually matter whether it's positive or negative. Your calculator is actually clever enough to work out the quadrants for you. So knowing that, let's try cos. Now, with cos actually in this particular example, I want to make even easier for you. With cos, we know that cos is negative all stations to Cape Town. So now that we've got the hang of the first way to do it, I'm going to make cos easier. Where is cos negative? Cos is negative in quadrants 2 and 3. Now how did we solve our cos equation? What we did is we did shift cos, and in this case we're going to do negative a half. And if we do shift cos of negative a half, our calculator tells us it's 120 degrees. So our calculator is already finding the quadrant 2 solution for us. So my first solution is that theta must be equal to 120 degrees. Plus K360, K is an integer. Now last time what we did is we did 360 minus the solution to get the second solution. Now there's actually an even shorter way, and it makes it so much easier, and so we're going to do it from now on. 120 degrees is here. But we know that cos of a negative angle is exactly the same thing as cos of that angle. We learned that in trig reduction. So if this is 120 degrees, of course we could do 360 minus 120 and get our second solution. But cos of negative an angle is the same as cos angle. So therefore, cos of negative theta, sorry, not negative theta, let me change it. Cos of negative 120 is the same as cos 120. So where's the second solution? The second solution is all the way clockwise. This is negative 120 degrees. So instead of doing the whole 360 minus, we're going to start cutting corners. And we're going to say, but hang on, I can just say theta is also equal to negative 120 degrees. And that's my second answer. Mustn't forget my plus K360. So when we do our summary in a moment, basically the only one that's difficult is sine. Tan has one solution, and cos's answer is just going to be the plus version and the minus version. Right, let's try tan. Tan is negative 1, not a problem. On my calculator, I go shift tan of negative 1, and my calculator tells me it's negative 45 degrees. Now where is that? What's going on here? Negative 45 degrees would basically just be in quadrant 4. Now that makes complete sense because tan is negative in quadrant 4. So therefore my first solution is theta equals negative 45 degrees. However, where's my second solution? My second solution is just 180 degrees later, or 180 degrees before, doesn't matter. So actually 1 and 2, both solutions together, are formed into one statement. Because I write plus K180, that will automatically generate that second solution. So negative 45 is the first. If you add 180, you'll get to the second. And so we summarize it in one line. Okay, hopefully we're getting there bit by bit. So my last question, just to practice, just to drive home each of these kind of methods, and then I'm going to write a little summary on the side each time, is question 3. So it says solve for theta in the following equations. Sine theta equals 2/3. Now for the first time it has this kind of given domain. So what have we been finding so far? We have been finding all the solutions that possibly exist in the whole world for the equations. Now that's called the general solution because it's all the solutions. What this question now says is, can you go find me the solutions, but only those that exist from 0 to 360 in this case. What this means notation wise, this means is an element of, so theta is in element of 0 to 360. So 0 degrees to 360 degrees. That's what I'm interested in. Now the moment they narrow down my domain, I just ignore this. I'm not going to look at this at first. I'll come back to worry about that in a second. I first find my general solution. Now how do I find the general solution for sine? I go shift sine of 2/3, and my calculator will tell me that. My calculator tells me it's 41. Now we normally keep 3 or 4 decimal places, but at the moment well, I'm not going to do anything with this angle, so I'm going to round it off, but I will show you in videos after this where I'm not going to round off, and you'll see why. Right, so what's my first solution? My first solution is simply 41,81 degrees. Don't forget your plus k360. And because this is a sine equation, what's my second solution? My second solution is 180 minus 41,81. So in this case, I'm going to get 30 is 138,19 degrees. Okay, don't forget that plus k360 all the time. Now this is called your general solution, because you've just found all the possible values that can possibly exist. Now just to quickly summarize, how do we find the general solution for sine? Well, the first thing we did is we do shift sine of the ratio. That's our first solution. Regardless of whether it's negative or positive, you just go shift sine of the ratio. What's our second solution? We do 180 degrees minus this whole angle that you find there. Put it there. So that's how you solve a sine equation. Shift sine of the ratio, and then your second solution is 180 minus that shift sine of the ratio. So 180 minus that first solution. Every single sine equation is solved like that. Whether it's positive or negative, your calculator automatically will generate the right quadrants. Okay, now comes the time where we go, hang on, but x was told to me that x had to be in a certain domain. So, but in this particular question, x had to be between 0 and 360 degrees. So, what we do then is we go look at the first solution, and we say to ourselves, would 41,81 classify in this range? And it is. 41,81 degrees is between these two values. Now I'm allowed to add 360 as many times as I want, and I'm allowed to minus 360. But if I add 41 to 360, I'm going to get over 400, and that's over my top limit. And the moment I minus 360, I'm going to get something below 0. So I can't add 360 or minus 360 because those answers won't be in what they gave me. Similarly, 138,19 is one of the solutions. And as soon as I add 360 or minus 360, I would be outside this domain. So there's actually only 2 answers in this particular question that fit the given domain that they gave me. Okay, so that's how we pretty much solve every sine equation. Right, how do we solve pretty much every cos equation? Well, we do shift cos of, in this case, negative a quarter. And my calculator tells me that's 104,4775, so 48 degrees. Now that makes sense because that would be quadrant 2. So that means my first answer for theta is that theta would be 104,48 degrees. And don't forget my plus k360. Now my second solution will just be the negative version of 104. I could do 360 minus, but it's just so much easier to just take the negative version. So in actual fact, we summarize these into one line by writing that. So my second solution is actually negative 104.48 degrees. So very similar to tan, we summarize both the solutions in one line because we're quite lazy. So how do we solve cos equations? Of course, we could do it how I first said we did it, or we can use the shortcut. And the shortcut is I am going to do shift cos of my ratio, but instead of trying to find a second solution, I'm going to say, well, the positive version and the negative version of that will work. Now, in this particular question, they didn't say if x is in a certain kind of domain, and so I'm leaving it in the general form. So now we know how to find the general solution of any cos equation. So, last one is tan. Tan theta equals 2. But they've told me that theta has to be in that domain. Now, first of all, we ignore that, and we simply figure out when is tan equal to 2. So we say shift tan of 2, pick up your calculator, shift tan of 2, and I'm going to round to 2 decimal places, and I get 63.43 degrees. And once again, the beauty of tan is that you can put both the solutions into one line. So theta equals 63.43 degrees. And instead of writing plus K360, if I write plus K180, it will automatically generate my second solution. Okay, but apparently theta must be an element, it must be between negative 360 and 360. Now that's not a problem. Therefore, theta must be, and you start off with the original answer. Does 63 fall into my category? Yes, it does. So 63.43 is acceptable. Now what I would do is I would add 360. And if I add 360, I get 423. Add 360. I take that back immediately. The question with tan, my apologies, it says I'm allowed to add 180 degrees. So if I add 180 degrees, I get 243.43. Now that's obviously just the second solution in the first 360, so of course that's acceptable. If I add another 180, I get 423, which is not acceptable. So I stop adding because I'm already out of the given domain. Now, so let me just write myself a note there. I added 180. But I'm allowed to minus 180 as many times as I want. So if I minus 180 from my original solution, I get negative 116.57 degrees. So that's definitely acceptable. And if I minus another 180, I'm allowed to just keep going as many times as I want until I get out of the range. Now I get negative 296.57, and that is in my given domain because I was allowed from minus 360. If I minus 180 again, I now get negative 476, which is now out. So there were actually 4 answers in this given range, or domain I should say, that were actually answers. So this is called my general solution, which you always found first, and then I found the specific solution in my given domain. Okay, so let me just write my little summary on the side here. How do we solve a tan equation? Tan equations are really easy because it's just shift tan of my ratio, and then you just write plus K180 because that automatically generates my second solution. Now I'm going to make another video on summarizing these 3 ways, how do you solve a sine, how do you solve a cos, and how do you solve a tan. So if you are feeling a little bit uneasy and you're not quite happy, you can watch the video summarizing it. Otherwise, you can launch directly into practicing from exercise 7.10. Well done.